So in this class, when we're going to solve problems where we need kinematic equations, we're going to focus on two basic types of motion. The simplest of these is motion with a constant velocity. Now, if we have a constant velocity and the velocity doesn't change, that means the acceleration is zero, because again, the acceleration is telling us how the velocity changes. Constant velocity means zero acceleration. If you have constant velocity, that means that because your velocity isn't changing, the final and the initial have got to be the same value, and so we're just going to relabel that as Vx. So this is simply, the Vx is telling us that it doesn't matter what point in time you choose to look at, your object's traveling with a single speed. And so we're left with an equation that tells you the position when you have constant velocity motion. Here's the equation that we've set up for constant velocity motion in the x direction. If we think about our tables, so we're going to put together tables to help us think about what's going on with these kinematic problems. Notice, you're always going to have zero in that acceleration slot if you know you have an object moving at with a constant velocity. And that means that your two velocity values, the initial and final velocity values, are always going to be the same. Now again, we set that up for the x component, but of course position and velocity, these are vectors, and so that means that we can have constant velocity motion in x, we can have constant velocity motion in y, we can even have constant velocity motion in z. So we obviously aren't going to spend much time worrying about the z direction stuff, but even thinking about motion in two dimensions, we can have problems where you need a constant velocity equation for what's to describe the motion in x, the x component, and a constant velocity equation to describe what's going on in y. The second type of motion that we're going to focus on is motion with constant acceleration. So constant velocity is the first one, constant acceleration is the second one. And so here, instead of our acceleration value being zero, what we know is it's not zero, but it also isn't changing. So the final acceleration, the initial acceleration, these values are the same, so we're just going to call it A. That's going to leave us with three equations. The first one is going to tell us, well, what is the velocity as a function of time? So how is the velocity changing as a function of time? And that's given by the final velocity is equal to the initial velocity plus the acceleration times time. I also have an equation that tells me about my object's position as a function of time. So again, here the final position is equal to the initial position plus the initial velocity times time plus 1/2 times the acceleration times time squared. So this position function is a quadratic equation. It's got a t squared term, a t term, and a constant. The last equation we've got, notice our first two were functions of time. The last equation is what you get if you eliminate time. So if I take these two equations and eliminate time using substitution, this is what I get. And so it tells me that the final velocity squared has got to be equal to the initial velocity squared plus 2 times the acceleration times the object's displacement. And so again, thinking about that table, well, here what we know is I'm going to have a non-zero acceleration, but it's going to be constant. Again, it's not changing. But what that does mean is, because I know I have an acceleration, that means that my velocities have to be changing. So the initial velocity and the final velocity in this case will not be the same. Velocity, acceleration, position, displacement, they're all vectors. And so we have these three equations that we can use when we think about constant acceleration motion in the x, or we've got a set of y component equations if we have constant acceleration motion in y, and again we have a set of z component equations if we have constant accelerated motion in z. One of the big things that we will focus on in working our kinematic problems is going to be initially what kind of motion do we have, because that's going to tell us which set of equations we can use.